First of all, I'm Edward Vanden Berghe, so I have to warn you, you're not going to get a demo. I'm neither as brave as Jan is or as inventive as Oriano is, so you'll have to make without a demo. But I hope that I'll still be able to convey some of the work that we've been doing here. So you see here 4 people listed as authors. Fabio will take over from me for the second half of this presentation. Nicolas Bailly and myself, we have a lot of experience in bringing different species lists together, trying to harmonize the name use in different systems. Nicolas through fish-based, myself through the Ocean Biogeographic Information System. Then Fabio and GP Coro are the people who actually made the application. And then I should also mention probably Lino and Anton, who have really helped us focusing our discussions when we had our weekly meetings on building this system. So big data, the term has been used several times already here. Big data also means that there is a need for data integration. And that need for data integration is even more so with biodiversity data, the data that Nicola and myself are mostly interested in. Because that biodiversity data collection often occurs in the framework of relatively small projects. So projects that are of restricted scope, but that we have to be able to aggregate in one database to be able to reply to some of the, I don't know what's happening here, yeah, to databases that are able to answer then questions that are that humankind is facing these days. So it's becoming also a very realistic possibility. A couple of years ago, having records of millions of databases was really the realm of specialists, but also now biologists are able to go to that type of database. So we need that integration to integrate those restricted scope databases into that massive database. Some of that integration will be intradisciplinary. Like, for example, if you have different sources for biogeographical data, you want to make sure that you call the same thing with the same name in all of those databases. There's also interdiscipline integration that we need, and that has been mentioned already several times here in the workshop. Like, for example, you want to enrich your biogeographical data with the physical oceanography, enrich it with the environmental parameters in which those animals were living. And then why do we want to do this? Of course, we want to assist in evidence-based management of living resources, also something that has been mentioned already several times here. Other problems that humankind faces is climate change, global warming, and so on. So this is a little bit another view of the biodiversity aspects of iMarine, in which we show the dependencies of the different activities on each other. So obviously there's going to be activities of accessing taxonomic names, there's activities of accessing occurrence data and so on. Then the lower part is all to do with species distribution modeling that we've been mentioning already a couple of times. But then that taxon name reconciliation is really playing a very central role in the whole process, because there's a lot of the other things that will depend on that, and depend also on the quality of the taxonomic name reconciliation. Like, for example, if you want to make sure that you discuss the occurrence data of the same species, all of the same species, whatever way that the species name has been spelled, then of course you have to do that taxonomic name reconciliation first. And then ultimately it's also going to improve the quality of the distribution modeling. So, taxonomic names are the keys, so they are really the keys to bind together the information on a single taxon from the different sources. But there can be, of course, some problems. A lot of variation exists in the way that people spell different taxonomic names. And then there's also, of course, different accidental misspellings. We'll see some examples of that later on. There's other problems, but that we'll not discuss today, also because they're a little bit outside the scope of our own activities within iMarine. That's synonymy, homonymy, and so on. So it's not always that the same name covers, or the same flag covers the same content. So some of the reasons why we do need that taxonomic name reconciliation is that a lot of people have problems properly spelling taxonomic names. Well, if you look at some of the taxonomic names, it doesn't come as a surprise. For those of you who are not carcinologists, the right spelling is the last one. But there's also much sillier reasons why people are misspelling, or why some of the names are changing. Like, for example, here someone has dragged down an entry in an Excel spreadsheet. And then instead of the herring always being described by Linnaeus in 1758, well, you get a whole series of names of authors. And of course, if the computer would see them as separate entries, if you don't, and a lot of different entries if you're not careful. So, yes, taxonomic names are the keys. We have to use them to make sure that we are talking about the same thing. But as you can see, taxonomic name reconciliation is a must. It's really a necessary and not a luxury. So there are some systems that have been built already by other people, but most of those existing systems, no, none of those existing systems, I should say, are flexible. So we need that flexibility because our user needs are not always the same. Like, for example, if we want to automate a system, then it's important to have a single answer from our system that is a very high probability to be the right answer. Okay? So the precision has to be very high. But then in other cases where we want to present a list of alternatives to someone who's manually going to go through that list, it's the recall that is important. So, and the existing systems don't offer that flexibility that we need there. But BiOnym obviously does offer that flexibility. Then also a lot of those existing systems are coupled to a single reference list, to a single taxonomic authority file. And that's something that we also want to avoid because there's people doing those things in different contexts. And if there's a mismatch between your taxonomic authority file and the names that you want to investigate, well, the only thing that you're going to do is to produce a lot of false positives. So we want to avoid that situation. And then also a lot of the existing systems do not have the throughput that we might be able to offer using an infrastructure like the one of iMarine. So to summarize, we need a flexible, highly customizable workflow-based approach for taxon name matching, where the user can control the inputs, also all the settings of the systems, of the various matches that we're going to use. We also need to integrate it into the iMarine infrastructure so that the output can be used as input in other processes. And then, as I said already, running it in a high-performance computing infrastructure. So in other words, what we need is BiOnym. And at this point, Fabio is going to take over.
Okay, Edward, thanks for your introduction. You have focused very well on the problem that the scientific community is trying to solve, and we hope we will contribute to solve. When we started designing BiOnym as one of the components that the iMarine platform could offer, we of course had a look at the existing state of the art. As Edward has already said, there were no existing system which could be as flexible and as capable of being user-controlled as the one that the scientific community might want to have. At the same time, we saw that in FAO, which is one of the partners in the iMarine consortium, there has been already in FAO has been already provided a solution which was developed for a totally different scope. It was called COMET, which is a concept matching framework. It was initially designed to fulfill the role of identifying duplicates among vessel data appearing in different registries. And this was developed with the support of the Japanese Trust Fund. At the same time, this product evolved and became mostly domain independent, so it could be reused outside of the domain of vessel data. This is why we decided to take the chance of incorporating Comet, integrating Comet inside iMarine, in specific when designing the BiOnym workflow. This framework, by the way, is provided with all the necessary building blocks and is ready for being easily reused. So the integration of Comet inside iMarine can be one of the many examples of success story inside iMarine itself, because the integration, the quests posed by this integration were easily solved. In particular, the infrastructure, the iMarine infrastructure, provided a perfect choice for providing input to this concept matching engine, at the same time to acquire the results of this process and made the same results available to all the other participants in the infrastructure. The core matching capabilities of BiOnym that were implemented by means of the Comet framework were already available by June 2013. They included, as you might see from the slide, a set of pre- and post-parsing processing rules, a parsing stage in which you can either use a parser provided out of the box as part of this solution or also leverage external parsers that were developed by other institutions. The nature of the matching process that Comet can provide is basically accomplished by means of what we call matchlets, which are very small units of business logic which are capable of extract the relevant information from the data you are comparing and provide a similarity score that is then weighted to provide the final score between the input data you are comparing and the reference data. BiOnym, as we all know it now, is basically composed of a modular architecture that enables developers to provide new functionalities and most of all to switch and replace the existing functionalities with what is most suited to their needs. So anyone, according to the BiOnym specification in terms of data interchange format, can write their own components that will replace the existing parsing or post-processing or whatever other stage of the workflow is available. Okay, this is, on one of those graphs that anyone is happy to stare at, but jokes apart, as a diagram, it tries to capture the more relevant stages inside the BiOnym workflow and the data boundaries between BiOnym itself and the existing external systems, being these systems outside iMarine or iMarine itself. So in light purple, you will see everything which is outside BiOnym, while in green, all that is currently part of the BiOnym offering. The stages in which we have divided this diagram are basically 5. 2 of them have been collapsed, and they are in random order, well, not so random order. The production of input data, where you need to extract from your databases the data which are subject to the comparison against the reference data. Then, of course, you have either to produce or access the reference data, and this happens by means of Darwin Core Archive files, which is one of the de facto standards in the scientific community when it comes to taxonomic data. These Darwin Core Archive files are converted by means of one of the BiOnym tool into the TAF, which is Taxonomic Authority File format, which BiOnym uses internally. So input data basically are transformed in the input data format for BiOnym. Pre-parsing and post-parsing rules are applied at this stage. In between, the data can be parsed. That is, a raw text can be split in the taxonomic atom according to one of the parsers. This parser data is then sent to the BiOnym matching engine. Here you will see just one single component, but possibly, being this a workflow, you can have multiple matchers chained together where the input of one matcher are indeed the output of the previous matcher. And in the end, of course, the matching results are stored and ready for evaluation. So where are we? As we said, the infrastructure is currently largely built. There is very little effort to be done to complete the actual implementation. We are currently in the process of developing a user-friendly GUI because the one we have now is more tailored on expert knowing what they are doing. We know that we are not that good at building interfaces, so we are now focusing on building a better one. At the same time, we made quite an evaluation on the results we can achieve with BiOnym, both in terms of efficiency, and we see that the speed of the computation we can achieve with this system, powered by the distributed processing infrastructure of iMarine, is compares extremely well with other systems. In certain circumstances, it can be from 1 to 2 orders of magnitude better. And most of all, we try to evaluate, with the help of Edward and the other people from the taxonomic community that joined the project, the quality of the results that we were producing. So we ran experiments on different data sets, some of which were synthetic data sets, which were misspellings introduced by means of simple algorithms that will change the input data. And in some other cases, we had data set coming from real raw names, as we can encounter them in many circumstances. In both situations, BiOnym was capable, also because it was, we could ascertain whether the results it has produced were correct or not. It was producing extremely good results in terms of accuracy, recall, and F measures. These are all measurements that all the people which are involved into statistics analysis are well aware of. This is an example of how the BiOnym interface currently integrates inside the statistical manager. When I say that we need to design a better interface, this is what we currently have. And although it works perfectly, it is probably far more detailed than what the casual user will expect. So basically, the first thing you can do is select your data. In this case, you are just inserting one single entry, but you can provide your own data set, or you can link to external data set which are available in the data space of the system, or the infrastructure. Then you can select one or many among the available taxon authority files, which are the reference data against which you want to identify matching between your input data. Then the second step is basically the composition and definition of the matching process, where you can select the parser you want to use, if any. Then you can select whether you want to have more accuracy at the expense of speed, or on the contrary, have more speed at the expense of accuracy. Then you start defining what are the characteristics of each single matcher which is involved in the process. You can have from this interface up to 5 matchers, but possibly the system is capable of having any. If you want to then visualize the quality and assess the quality of the results you get with BiOnym, you have plenty of options, because as we said, the system is producing results in standard formats which can be easily interpreted and used to produce graphs like this. You will see a 3x graph, also called Definetti, and an AUC curve, which were plotted according to some of the results we had. So where do we need to go from here? We still need to validate the system, not in terms of the quality of the results it can produce, but in terms of, will the biodiversity community use this system? Is this valid to fulfill the purpose they want to use it for? Mostly important, we have a sustainability issue, because as we all know, iMarine, as we all know it, is soon to end, and we are now facing this dramatic question: who will take over the maintenance of the overall infrastructure and of BiOnym as a small part of it? I would like also to stress that BiOnym is a tool. It's not something that lives on its own. So it is just basically a means to an end. And it is perfect from our point of view, as we are not only software developers or software engineers, but also scientists and marine biologists. It will be a nice tool to support the ecosystem approach to fisheries. Okay, these 2 slides following are just an example of how BiOnym fits in its environment. Here you will see that we can use its facilities to convert Darwin Core file into the format it needs to have data to perform the comparison, and this is a way in which you can import this Darwin Core archive to produce tax authority file. We aim possibly at integrating the results from BiOnym, as Edward said, inside different scenarios like biodiversity maps generation, or more generally speaking, in all those scenarios where having a correct classification of species is relevant to the results you want to achieve in that